When we talk about taste and smell, we know that people have a very specific liking or dislike for some foods. This poor kid hates his broccoli. Why? Well, he might be actually an individual that we call a super taster. And these are individuals that tend to dislike things like cabbage and broccoli because they find them to be very, very bitter. And what we look at is actually a different concentration of chemoreceptors in their taste buds than in other individuals. Pretty amazing. How's your taste bud actually work? Well, for your taste buds, they're chemoreceptors, but so are your smell receptors in your nose. They're also chemoreceptors. The difference is your taste buds are looking for molecules in solution. Your nose is looking for molecules in air. Okay, so the difference between our chemoreceptors here is whether or not they're in liquid solution or whether or not they're actually in airborne. Okay, now the thing we have to be careful is that taste and smell often interact. Think about the last time you had a cold. How easy is it to taste things when you have a cold? Or if you can't remember, pinch your nose shut the next time you eat something and then eat it without your nose pinched shut. We are very dependent in our brain and our conscious awareness of what we're eating to know both what it smells like and what it tastes like. This is important because if you bring something up to eat and it smells wrong to you, this is how we actually distinguish things that are spoiled and that you don't want to eat. We told you for years, I'm sure, that you have 4 taste receptors in the taste buds on your tongue, and we'll show you that. Sweet, salty, sour, and bitter. In recent years, we've added a 5th taste known as umami, or this savory taste associated typically with meats and cheeses. Now, when we look at this, we always used to give you a tongue diagram and say that you could only taste bitter at the back of your tongue and you can only taste sweet at the front of your tongue, and we've learned that this is a lie. Yes, you have different concentrations of different taste receptors or chemical receptors in different areas of your tongue, but you have receptors for taste all over your tongue. And the reason that is not because of these papillae on the surface. When you burn your tongue and you get those bumps on your tongue, you haven't burned off your taste buds. Don't worry, okay? The taste buds are actually deep down inside your tongue. These chemoreceptors are deep in pores in your tongue. The reason you can't taste anything when you've burned your tongue is because you've swollen the papillae and the liquids can't flow down in here to actually get sensed and send signal to your brain. So what we look for with both taste and olfactory, or your nose, is to look for this connection between your memories of what you've actually tasted or smelled before and what you're currently tasting or smelling. So the chemoreceptors in your nose look very, very similar. We get these cilia that are going to trap particles and send that information through action potentials, of course, into your brain. And we actually associate this olfactory bulb, this collection of nervous information you see here. It sits right against your brain. And what we see is that it directly sits against your memory center of your brain. There is literally a direct connection between your olfactory bulb and your memories. So that's why when you smell something and it reminds you of a place or a time or an event, this is why 80 to 90% of what you actually taste is due to your sense of smell and this link to your memories.